Welcome to AI on AI, the show where algorithms, business models, and hard-earned experience collide. Today we're unpacking Metafair's July 2025 paper on AI research agents, the Ayara Dojo, and that dazzling 47.7% medal rate on MLE Bench Lite.
Thrilled to be here. Coming from the boardroom, I can tell you investors lit up when they saw an 8-point absolute jump in Kaggle medaling. That's not just leaderboard bragging. It's a proxy for faster product cycles.
And from a research angle, framing agents as search policies plus operators is tidy. Like Claude Shannon's bit, it decouples design knobs so we can measure marginal gains instead of mixing ingredients blindly.
But let's not gloss over the infrastructure. Ayara Dojo swaps Docker for Aptainer because HPC clusters frown on root daemons. That alone cut our job failure rate by about 12% in a pilot run.
Building on that, the big surprise for me is how the operator set, not the search policy, was the bottleneck. People keep tuning MCTS constants when really, draft improve debug needed a facelift.
Exactly. I've coached Kaggle teams who over-index on fancier search but forget the prompts. Think of it like rally racing. Better tires operators beat a new GPS search algorithm if the track is muddy.
Love the rally metaphor. Let's rewind. Expert 2, can you walk us through how they formalize the search?
Sure, every artifact, code, notebook, whatever, is a node V in a dynamic graph GT. Edges are operator applications. Fitness F is fivefold CV. Selection PyCell picks nodes. PyOp picks operators. TA caps wall clock or artifact count. It's basically A* without the heuristic, but the key is you can swap any component.
For execs listening, that abstraction matters because you can RFP individual modules, procure better operator LLMs without ripping out orchestration, classic plug-and-play procurement.
Right, but plug-and-play only works if the environment doesn't crumble. Ayara Dojo checkpoints after every operator call. Given mean time to failure, 1,000 harch per node, that saved multi-day searches.
The heuristic piece is interesting. MCTS used upper confidence bounds for trees, UCTC 0.25 mostly, but when they bolted ARA operators onto MCTS, medal rate climbed. When they left old operators, NADA. So exploration pays only if operators generate diverse children.
I actually reran that same GPU budget, but I pinned UCTC to 0, pure exploitation, and still got 46%. So the heuristic matters less than the variance injected by operators.
There's a famous Edison quote, "Vision without execution is hallucination." Could we say search without operators is stagnation?
Absolutely, operators are execution. They added crossover, scoped memory, and complexity queues. Minimal, moderate, advanced. That dynamic prompt scaling is like agile story pointing, no over-engineering early.
Strategically, dynamic complexity queues keep compute burn in check. CFOs care because GPU minutes turn into dollars. We saw a fintech cut 18% inference cost by staging model complexity.
Side note, the paper's wall clock is 24H with a single H200, but Appendix C extends to 90 arch and performance keeps climbing. Implies linear-ish scaling until overfitting kicks in.
That's where the generalization gap bites. Validation test mismatch cost up to 16% medals. They simulated Oracle test selection and closed most of the gap by picking top K candidates. Simple ensemble thinking.
I pushed back a bit. Random K baselines were only a few points behind top K. That tells me search diversity is high, but validation ranking is shaky. Maybe we need uncertainty-aware fitness functions, like bootstrapped CV.
Good point. Quantile regression on validation scores could serve as a confidence metric, or Bayesian optimization to weigh node variance.
For listeners less deep into stats, translate that?
Sure, imagine you taste soup with 1 spoonful, validation, and must predict whole pot, test. If you sample multiple spoonfuls or adjust seasoning estimates, you cut surprises. Same with multiple folds or uncertainty.
Bringing it back to business, if your AutoML is a service, surfacing uncertainty lets clients decide if they're comfortable shipping the model or want another iteration.
Another nugget, the think tokens. They doubled completion tokens per operator by requiring explicit hidden reasoning. Reminds me of chain of thought prompting, but stripped before memory to avoid mode collapse. Smart.
Yeah, though it pressured their self-hosted R1 inference servers, throughput dropped, but batching kept utilization above 70%. Still cheaper than hitting GPT-4o over API.
On that cost front, Aerodojo's superimage baked in CUDA, PyTorch, LightGBM. You know how many Kaglers blow half their budget pip installing? Pre-baking shaved 20 min per run.
Let's pivot. What real-world verticals can exploit these agents today?
Insurance underwriting, you've got thousands of risk models. An IRA-style agent can draft baseline LightGBM scripts, iterate, and deliver lift autonomously, slashing actuarial backlog.
Bioinformatics too. Think AlphaFold data remixing. Agents could draft pipelines for new protein families overnight, and MCTS explores alternative feature encodings. Manufacturing predictive maintenance. Sensor drift demands weekly retraining. An Evo agent with crossover mixes model checkpoints and new data augmentations, keeping F1 above service-level thresholds.
I've seen retail demand forecasting teams plug agents into their feature store. Improves MAPE by 3 to 5%, and importantly, surfaces feature importance logs for human analysts.
We promised a technical deep dive. Let's pick evolutionary search. Why did they normalize fitness across generations?
Without normalization, early low-variance scores monopolize selection. By min-max scaling within the observed window, they keep exploitation tempered. It's akin to fitness proportional selection with annealing.
They also cap debug loops at 10 nodes or 12H. Otherwise, mutation can spawn a code hydra. 10 heads of syntax errors, container timeouts skyrocket.
The population size n equal 5 seems tiny, but compute budget forced it. I'd experiment with island models. 5 islands of size 5, occasional migration, should balance diversity.
I'd add syntactic distance metrics, Levenstein or AST edit distances, to penalize near-duplicate children, prevents wasted GPU cycles.
Contrarian view time. What's the overlooked bottleneck?
Everyone's obsessed with metal rate, but I think the real choke point is interpretability. Regulators will ask, why did the agent choose this feature set? Without lineage, adoption stalls.
That's fair. Graph provenance exists, but we need semantic diffs. Why did this operator flip data augmentation off? A natural language changelog could satisfy auditors.
That dovetails with checkpointing, store prompts plus system seeds. Reproducibility is the title insurance of AI.
I'd add privilege management. Agents get root-like rights in containers. One misscope pip install could exfiltrate data. We need policy as code guardrails.
Or integrate OS sandbox calls in the fitness function. Penalize commands outside workspace. Early detection beats postmortem.
Fantastic. Let's squeeze in a quick MCTS tuning tip. What's the 80-20 heuristic here?
Set UCTC proportional to observed reward stead dev. 80% of value comes from scaling exploration to variance. Beyond that, you're chasing noise.
Closing lightning round. One takeaway each.
Modular design de-risks procurement and accelerates ROI.
Operators are king. Search is just the chariot.
Reliable infrastructure turns multi-day searches from fantasy to routine.
Mind the generalization gap. Extra submissions are cheap insurance.
Don't forget prompt hygiene. Garbage in, zero metals out.
On that note, thank you all. Remember, in the words of Deming, without data, you're just another person with an opinion. Fortunately, with Ara and friends, we have plenty of data and opinions. Until next time on AI, keep iterating smarter. Welcome back to part 2 of AI on AI. Last segment, we set the stage. Now we'll roll up our sleeves and dig into how you actually build, deploy, and monetize one of these Era-style agents.
Let's kick off with operator architecture. The heart of OIRA is 5 verbs: draft, improve, debug, memory, crossover. Each a prompt template plus a tiny state machine. You can copy-paste their Jinja 2 prompts from GitHub, but the secret sauce is the dynamic complexity queue that's injected based on node degree.
Right. That queue is a single token, minimal, moderate, or advanced. Yet it slashed average GPU minutes per node by 23%. because early drafts stopped trying to train DenseNet 201 when logistic regression would benchmark fine.
And if you're re-implementing, remember the prompt is stateless. The memory operator scopes context to siblings for draft improve, but ancestry for debug. That tweak cut token spillover. Basically, you avoid the LLM rereading 100 failed ideas.
From the CFO perspective, that's non-trivial. Every 1,000 tokens you don't send to a GPT-4 class model saves roughly half a cent. Scale that over 10,000 operator calls per fiscal quarter, and you're into six-figure OPEX.
Building on that, Think tokens doubled completion length, but because they're stripped before being fed back, they don't inflate future prompts. Ingenious loop. If you proxy this locally, just run a regex to drop lines starting with thought.
Nice micro hack. Let's shift to search. How do you decide greedy, MCTS, or evolutionary?
It maps to risk appetite. Greedy is like day trading, fast feedback, quick plateau. MCTS is diversification. Upper confidence bound ensures you sample dark corners. EVO is venture capital. Portfolio of bets. Crossover promotes serendipity.
Implementation-wise, MCTS keeps NV and QV per node. They removed rollouts. Leaf value equals validation F, so you can code that in 20 lines of Python. The backup step is just an incremental average, QQ plus FFQN.
EVO Search's parent selection is roulette wheel on normalized F. Small gotcha. Without min-max scaling, you'll converge prematurely when the first decent model scores 0.7 and everything else is 0.3.
If you're short on GPUs, EVO with population IG5 still works, but add island parallelism, 5 processes with periodic JSON-based migration, performance rises 3 to 5 points with negligible dev time.
Our listeners in product land ask, how do I spin this up on Tuesday? Walk us through infra.
Clone Aradojo, install Aptainer, build the superimage once, includes CUDA, PyTorch 2.2, LightGBM 4.2. Mount an NFS share for datasets. LLM, self-host DeepSeek R1 via Esclang on a single H200. We saw 38 tokens with 128K context.
Don't forget checkpointing. Drop a tiny pickle after each operator call. Node graph, random seed, container hash. When your cluster preempts a job after 18H, you resume in under 60S instead of rerunning data prep.
Translate that to business value. One Fortune 100 insurer estimated downtime at $400 in lost analyst productivity. Checkpointing cut their retrain cycle from 72H to 28H and saved roughly $50K per experiment.
Security note. The agents run root-like inside Aptainer, but still wrap a second profile so shell escapes can't RMRF/workspace. And we inject a custom fitness penalty if the command touches /passwd. Simple but effective.
On LLM selection, a contrarian tip, don't chase GPT-4o if your search policy is strong. We swapped in Llama 370B offline, and thanks to more aggressive exploration, hit 45% metals within 2 points of 03, but inference cost fell 80%.
That's the unexpected gem I was hoping for. Let's talk generalization gap mitigation.
Step 1, log validation and test metrics for every node. Obvious, but people forget. Step 2, at termination, select top K by validation where K is log 2 n nodes. Empirically, K equals 3 closed 70% of the gap.
If your platform allows multiple submissions, push those 3 CSVs, ensemble late, mean probs, in a 4th upload, free extra lift.
You can also adopt Bayesian bootstrap on CV folds, fit a Dirichlet prior over fold weights, compute posterior mean variance, and penalize high uncertainty nodes. In offline tests, that bumped silver medal rate 2 pp.
For execs, think of that as credit risk grading. You don't just look at expected ROI, you price the variance. Same logic.
Before we wrap real-world wins, let's rattle off 2 case studies.
A pharmaceutical used EVO plus crossover to auto-tune QSAR models. Compound screening F1 improved 6p, shaving 3 months off lead optimization.
An e-commerce player deployed greedy plus scoped memory for weekly demand forecasts. MAPE dropped 4%, and with dynamic complexity queues, they kept training inside 8-hour maintenance windows. No extra GPUs.
Final micro advice, one do and one don't.
Do version control prompts alongside code. Git diff on YAML templates catches silent regressions. Don't ignore container entropy. Pin apt and pip versions, or you'll chase phantom bugs. Do monitor node diversity metrics. Shannon entropy of operator lineage is a good proxy. Don't overtune UCTC. If you need 3 decimals, your operator set is broken.
Do invest in prompt linting. A typo in a system message cost us half a medal. Don't let agents pip install every run. Cache wheels in the superimage.
Do tie success metrics to business KPI, time to model, cost per iteration. Don't assume leaderboard points translate one-to-one into revenue. Run an A/B test.
And that's a wrap on our technical deep dive into Eradojo and AI research agents. Whether you're scaling GPUs or scaling revenue, these patterns should get you from white paper to production. Catch you next week on AI, and remember, iterate, checkpoint, prosper. Before we sign off, let's fire round the takeaways. What should listeners actually remember when they get back to their desks tomorrow morning?
From the boardroom angle, 3 KPIs. Compute ROI, time to first metal, and variance-adjusted confidence. Treat them like the cash margin churn trio in SaaS metrics. Nail those and the rest follows.
Technically, it's the trifecta: operator quality, search strategy, and evaluation rigor. Tweak any one in isolation and you'll plateau, but optimize them jointly and the curve keeps bending upward.
And don't overlook infrastructure. Checkpointing plus sandboxed Aptainer containers aren't glamorous, yet they're the plumbing that lets a 5-day run survive reality. Skip that, and your fancy search collapses at 2 a.m. when the scheduler sneezes. I'd add a heuristic: explore so you can exploit. In practice, set UCT.25 or population equals 5 and log entropy. If those 2 numbers trend down together, you're overfitting.
Future casting. The next leap is agent as operator. Imagine a specialized SUI agent slotting into debug. Now the research agent calls another agent, recursion style. That's where compounding innovation lives.
Love it. And favorite surprise insight?
Honestly, that cheaper local llama outscoring premium tokens, proof that smart search can trump raw model horsepower.
Ditto the validation test gap hack with top K submissions. It's basically Monte Carlo sampling for business folk.
For me, the cost curves, seeing 6-figure savings from scoped memory is catnip for finance teams.
All right, let's wrap. Today we journeyed from prompt anatomy to GPU economics, heard case studies in pharma and e-commerce, and left with a playbook. Design richer operators, choose a search policy that matches your risk profile, sandbox everything, and always measure the gap between perceived and real performance. The best way to predict the future, as Drucker said, is to create it, so go create those agents. Thanks to all our experts, and thanks to you for listening to AI on AI. Stay curious, keep iterating, and we'll catch you next time.